Hello and welcome. In this video we will be using blueprints to create fake 2D dynamic light as well as a simple material to go with it. I would like to give credit to How To UE4's tutorial on YouTube for creating this concept. However, his video is in another language and 31 minutes long, so I figured I'd recreate his concept in a shorter video in English with some very minor tweaks that I believe improve its overall usability. So without any further ado, let's get started. First, I'm going to right click and make a new folder. I'm going to call this fake light, and I'm going to open that folder, and then we're going to make inside of that folder our placeholder material. So right click, go to material, call this light source, and then we're also going to make our blueprint. But first I want to go into the light source and real quickly set up a parameter that we will be using. So right click, and we want a vector parameter, and we're going to call this light color. And I'm just going to attach this to the base color for now, and that should be the only thing we need to do for this placeholder material. So apply and save. We can close that out, and now we're going to make our actor for our fake 2D lighting. So right click, go to blueprint class, click actor. I'm going to call this BP_fake 2D light. We're going to open it up. So in this fake 2D light, we need a couple of components. The first one we need is a procedural mesh. So click the add component, type in procedural mesh. We don't need to change anything on it. And the next component we want is a collision sphere. And I'm going to call this one light sphere. And this light sphere is just purely, when we place it in the world, to represent the extent of our light so that we can better make decisions when we're trying to use this on the fly. So this light sphere has a radius, and that's what we're going to be updating in the world. So let's go to our construction script, and we need to make a variable, and we're going to call this light distance, and this is how far out we want our light to travel in Unreal units. So we're going to call this light distance, and it's going to be a float. And then we're going to also set it so that it is public, so you can click the I or check instance editable over here, and compile and save. Then we're going to drag in the light sphere, and off from the light sphere we're going to set its radius. We're going to set the radius to the length, or the light distance length. So just hook those up, and now when you place this into the world and you change the light distance value, the sphere will change to reflect the distance in which our light will travel. So I'm going to compile and save, and I set light distance just to 100. So let's come to the event graph. We won't need the event begin overlap. We will need the event begin play, and we will need the event tick. So let's think about what we got to do here. So our two end results are going to be a mesh with a material that we can make changes to, and then we need the ability to update that mesh once we've created it. So let's start there at the very end, and we know we're going to make this mesh out of a line trace, but we're going to start at the very end. Let's pull in our procedural mesh, drag off of it, and we're going to create. So type in create mesh section, and then from here we need three variables. So the first one's going to be our vertices. It's just going to be an array of vertices. The second is going to be an array of triangles, and all this is, as it says, an index buffer indicating which vertices make up each triangle. We're not going to have normals, but we will need UVs because we're going to apply a material. We don't need vertex colors or tangents. So I'm just going to promote these three arrays to variables. So I'm going to right click, and I'm just going to call them what they are on the node so that we don't get confused later on. And if I misspell these, I'm not going to correct it. So first one is vertices, second one is triangles, and then UVs. So we have these three arrays that we're going to have to populate in order to create a mesh section. So let's assume they're filled out, and we have our mesh section. So the next thing we need to do is apply a material to it. So I'm going to drag in the procedural mesh, drag off and set material. And we want to set this in the element index 0, so that doesn't need to change. And the material we're going to use is that placeholder material we created. So get the light source. Once we've created that material, we need to create a dynamic material instance. So I'm going to drag in the procedural mesh. I'm going to type in create dynamic material instance. So this will let us change the material in real time once it's been made, and it's going to use the same light source. So this is saying set the material in index 0. This is saying reference the material in index 0, and that it is light source. We know it's light source because we set it to light source. We don't need to name it. And then we're going to drag off from the return value of our dynamic material instance, and we're going to say set vector parameter value, and that vector value is the one we just made, and it was called light color. And I'm going to promote this value because this is what we will change when we want to change the color of the material on the mesh. So I'm going to right click, promote to variable. I'm going to call this light color. So anytime light color would change, we need to update the parameters of the material. So I'm going to create a custom event instead of making a function or anything else, because this is just something we can call whenever, and it's going to be called update color, and it's going to be connected right there. So we have a material, we can change the color on it. So next we need to be able to update the mesh sections we've created instead of creating new ones. So let's drag in our procedural mesh, drag off of it, and we're going to call update mesh section. Since we already have our, as it says, index buffer indicating vertices that make up the triangle, we don't need that, but those vertices will change, and so will the UVs. So we need to plug in our vertices, we need to plug in our UVs, and that will continuously update the shape of our fake light. We don't need to plug anything else in it. But now, once we've created the mesh, we no longer want to create more meshes, so we need a branch that will switch us to only updating and not creating. So I'm going to press B, left click, and then drag off for true and drag off for false. And I'm going to promote this to a variable, and I'm going to call this be created mesh. So if the mesh has been created, we only want to update it. If it hasn't, then we want to create it. So once it's created, we can come over here, and I'm going to alt drag in, and I'm going to set created mesh to true. So this will be our end result. We will have a mesh that'll be created using these three arrays. We will apply a material to it that we can update on the fly by calling this update color custom event. So in order to create this mesh now, we have to fill out these three arrays. So let's start with the vertices, because we know that we're going to create them through a line trace. We can't start making triangles if we don't have vertices. So let's come up here, and we're going to get a line trace by channel, and we don't want the multi, we want the regular line trace. So this line trace needs a start and an end. Well, our start position is going to be our actor's location, so get actor location, and our end position is going to be our actor location offset by our life distance value. So I'm going to right click and promote this to a variable, and we're going to call this end vector. I'm going to drag it down here, and we know it's going to be from this end vector is going to be calculated by offsetting our actor location by our light distance. To do that, I'm going to drag off of get actor location, and it's going to be a vector plus a vector, and we're going to add the end vector to it. But we need to set our end vector. So I'm going to come out here, I'm going to alt drag in end vector. I'm going to split this structure pin because we only need to change the x-axis, because that's the direction in which our line trace will be going. It'll be going on the x-axis, and then we'll just rotate it as we need. So we know we need to offset that by light distance. So you can just drag that in and hook it up. Don't need to make any changes to it. And that will give us our line trace start and end. So I'm going to connect these up, and we will need to loop this line trace for every polygon we want to generate, but we'll come back and do that in a second. I just want to fill out the line trace once before we do. We need a couple of things from this line trace. We need to know if it hit something, and if it did, we need to know where it hit. If it didn't hit something, we need to know where the trace's end would be. So I'm going to promote the return value. I'm going to call this be line trace return. And if this hits something, then we need to get the location it hit at. If it didn't hit something, then we need to know where it ended at. So I'm going to drag off of the off hit. I'm going to type in break. We're going to get these results. So I'm going to promote location to a variable. We're going to call this line trace location. And we need the end hit just in case it didn't hit anything. So I'm going to promote that to a variable. I'm going to call it line trace end. So this won't give us the exact value we need. We need to offset it by our actor's location. So I'm going to type in get actor location, and we're going to subtract a vector minus a vector. We're going to subtract the location, and we're going to take away the get actor location. And we're going to do that for both. So I'm going to drag off vector minus vector, put the end location in the first slot, put the actor location in the second slot, and that will give us an offset of the location for our trace location and our end location. So once we do that, next we need to update our end vector so that the next time we go through this loop, it will rotate it so that we can create a triangle going in 360 degrees, because we're going to be creating a circle. So in order to do that, we need another parameter. We actually need two parameters. We need to know how many polygons we're going to have to begin with. So I'm going to create a variable. I'm going to call it polygon, and it's going to be an integer because we can't have half a polygon. And then the next thing we need to know is our line trace angle, and it will be a float. And then to get our line trace angle, we're going to come over here to event begin play. I'm just going to drag it up a little bit, and we're going to hold in Alt and drag in line trace. And line trace is going to be 360 divided by however many polygons we're going to have. So float divided by float. The top value will be 360 because that would be a complete circle, and we're going to divide it by however many polygons we're going to need. So I'm going to drag that in, get, and then hook it up, and it will convert itself. That will give us the angle at which we need to rotate our line trace to continuously generate enough sections to make a circle. And I'm going to go ahead and set this polygon value. I'm going to compile and save. I'm going to set this to 100, and we have an error, and it's down here, and this is fine because we will set it up later on. But right now we don't need to worry about it. Or maybe I just didn't save the material. Either way, we'll fix it when we get to it. So I'm going to come over here, and now we're going to change our in vector. So get in vector, and we're going to set it. We need to change the y-axis of our in vector because we're going to be rotating it. So I'm going to right-click, rotate vector. I'm going to split B, and then A will be our regular in vector that we set before we go into the loop. But our y value needs to change, and it needs to be our line trace angle. And then we can connect that up to our in vector. So that the next time we come through this loop, it will rotate the line trace, and we can create triangles to create a circle. So once we've done all of this, we now need to know what, if anything, did we hit. So I'm going to hold in B and left click to create a branch, and I'm going to drag in line trace return. If it's true, we hit something. If it's false, we didn't hit anything. So if it does hit something, we need to drag in our vertice array, and we need to add an element to it. It needs to be whatever we hit. So in this case, it'll be our line trace location. Once we do that, we also need to add a position in our UV array. So I'm going to drag in UV. I'm going to drag off of it, and I'm going to type in add because we're going to add an element. I'm going to split this X and Y. So since this is a UV, the lowest number can be 0 and the highest number can be 1. So we need to clamp any value we get needs to be clamped to a between 0 and 1. So we're going to type in right-click, map, range, clamped, because we want to clamp. The value we will be clamping will be the length of our line trace location because we hit something. So I'm just going to Control-C, Control-V that, and we're going to drag off and get its length, vector length. So this is the value we're going to clamp. And we need to know our light distance as well because it's going to be our in value. And we're going to hook it into our in range V, and then our output is going to be our output is going to be between 0 and 1, so 0, and then output range B will be 1. So it'll convert these values to be between 0 and 1, and then we're going to set that to our X. This is going to be a solid color, so it doesn't really matter. Compile and save, and then we're going to come over here, and if we didn't hit anything, then we need to know our end location. So I'm going to Control-C, Control-V, just pull that down. If it's false, we don't want the line trace location, we want the line trace end. And pull that back, and I'm going to pull back in our UV array. I'm going to get it, I'm going to add another element to it, and this time we're just going to set the X value to 1. And that will give us our UVs as well as an array of vertices to use to create triangles. But this needs to go through a loop for each polygon we have now that we have our polygon variable. So I'm going to drag that in and get it. I'm going to drag off of it and type in for loop. And we're going to loop for every polygon we have, so it needs to be our last index, not our first. And I'm going to hook these up. straighten things out. Okay, so now we have an array of UVs, we have an array of vertices, and we're ready to start filling out our array of triangles. So I'm going to zoom out and drag this down to give us some space. So once this is complete, we can start filling out our triangles, and to do that we need an offset value. So I'm going to come over here in the variables, I'm going to type in triangle offset, and it's going to be an integer. Every time we go through the loop and it's completed, it needs to be reset to 1. So I'm going to set it to 1. And then next we're going to go immediately into a loop. So drag off and type in for loop. And this for loop is going to be our number of vertices. So I'm going to drag in our vertice array, drag off of it, and type in length. And this needs to be offset by 3 because we need to start counting at 0, not at 1. Also, we're going to be using the center vertice for every vertice, and then the very last vertice is going to use the very first vertice to create a triangle. So we're going to drag this off and subtract from it integer minus integer, and we're going to subtract 3, I believe. And that's going to be our last index. So the first thing we need to do is for every vertice we have, we're going to start generating a triangle. So pull in triangle, get, and then add an element. And then that element will be populated. So drag off and type in for loop. We're going to have a loop inside of this loop. And its last index is going to be 1. We're going to start at 0 and go to 1. And we're going to drag in our triangle array again. Drag off of it, type in add, and it's going to be the index plus, so integer plus integer, our triangle offset, and once this has completed, we need to increase our offset by 1, and then we'll fall back to the last loop and we'll be redoing it. So this needs to be control click, drag in triangle offset, and then plus plus to increment it, and this will increase it by 1 and then reset it to the new value. And that's all we need to do to populate our triangles. So once this array is complete, we'll plug it into this, which will update or create a mesh as necessary. Okay. So if you run all this right now, you will encounter some problems. First off, we have an error with the material, but also every time that this gets executed, we need to repopulate all of those arrays. And as it stands, it will just continuously add more and more to the array each time it does. So we need to clear out all the arrays. So I'm going to start with UV. I'm going to drag it in, get, drag off, type in clear. Then I'm going to pull in my triangles array. Clear, and then my vertices array, I'm going to drag it off and clear, also we need to add an element to this vertice array before we get started, so I'm going to drag off of it and type in add, and we just need 0, 0, 0. And we need to go ahead and do the same for our UVs. So I'm going to drag in the UV array. I'm going to type in add, and it needs to be 0, 0. So assuming I haven't made any mistakes, it should work now, but we're going to take this a step further. And for the tick, we're going to drag off and make a sequence. The second part of our sequence is going to evaluate whether or not the light color has changed. So to do that, we need another variable. So we have our light color. We need to right click and duplicate it, and we're going to have a new color called original color, which is sort of misleading, but it'll work for us in this situation. And I'm going to put this on a delay, so it's only every 0.2 seconds it'll evaluate whether or not the color has changed. I'll hold in B and make a branch, and we're going to compare light color to our original color. So get, drag off, equal, equal, and then set that to original color. If they're the same, then we don't need to do anything. If they are different, Then we need to update color. Once the color has been updated, we want to set our original color to our new light color. So I'm going to Alt drag in original color, and we're going to set it to light color. And then we're going to come up here to our event begin play. I'm going to move it back down over here. When we start, we want to set our original color to our light color once again. So set and light color. Also, we want our light color to be public, so I'm going to click the eye, or you can click the instance editable check mark. We also want our polygon count to be editable once we place it in. I'm going to check that and make it public. Assuming I haven't made any mistakes, this should be all we need, so let's go finish the material. I'm going to compile and save, and I'm going to open this material. First, we want this to be additive, so click this and set the blend mode to additive, so it'll just add to whatever's in the scene. We're going to plug this into emissive, but we need to multiply it by a value, so I'm going to right click and get text coordinates. From that text coordinates, we're going to mask R, so type in mask, get a component mask. We're going to uncheck G, we only want R, and I'm going to pull off of this and do a 1 minus, and then that 1 minus is going to go into a multiply. It's going to go in the bottom slot, it doesn't honestly matter. This is going to go in the top slot. We're going to put this in our emissive color because we're not using a lit material. And we're going to apply and save. If we go back to our fake lighting, if we compile it and save it, there shouldn't be any errors, but I just realized that this branch will continuously only update the mesh section because we didn't set it to false. So click the create mesh, set it to false, compile it and save. Now if we go to our test map, and if we drag in our fake lighting system we just built, I'm going to make 2 copies of it. So I'm going to alt click and drag so we have 2 copies. This first copy, I'm going to change it. I'm going to leave its lighting distance at 100. I'm going to set its light color to blue. And I'm going to change the polygon count to 20 so it'll be super low resolution. I'm going to come over here to this one. I'm going to change its distance to 200. I'm going to set its value to red. I'm going to set its polygon to 500, so it'll be a really high resolution because we'll have 500 ray traces to build our triangles. So if we press play, you'll see that this one, if we move it around, it's really chunky, and you can see its edges. If you move this one around, it's really fine and really detailed and adjusts really good. So you can't change any of these values in the editor, but you could have nodes or within the level blueprints or the character blueprint. You could have things that call out and change those values, and they should update in real time. So that's pretty much going to be it for this video. If you enjoyed this video, please consider subscribing and liking this video. Also, if you have any questions or comments or suggestions, just please hit me up in the comments down below or contact me through any other medium, and I'll see you in the next one.